how we roll, man. Some rock, some win, some 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 win, man.
Hello everyone. So you might have seen that I forgot to change the intro and it's still the old intro. Whoops. It's not like there's more than 100 people watching me fuck up, right? So it's gonna be fine. Oh well. In any case, Andrew, please take the stage.
Maybe sometime later this year after we all get our vax. But for now, we're doing a Twitch show. So yeah. So this was was 7 months of work. I don't know if you got a chance to read the release notes. I don't expect anyone to read all of it. But that's why there's this little table of contents here that you can thumb through and see what kind of changes pique your interest. A lot of people were interested, especially in reading this section, reworked memory layout. There's some insights you can take away for your own projects in there. So that might be a section you could have a look at if you want. But yeah, a lot of work. A lot of different people helped with this release, and it's just progress on a lot of fronts. And I'll show you some of the work. So the main focus was this part for this release cycle. And this is also going to be the main focus for the next release cycle. I was hoping that with 0.8, we would actually be able to finish it and ship it. I was hoping, but I wasn't sure it would be possible. With the next one, though, I'm actually confident. I actually think we can do it. I think we can ship self-hosted with 0.9 in about 7 months from now. So that's, and I think you can see, if you look at the progress that we've made this far, you can see why I have more confidence this time. So let me just kind of show you around, give you a little tour of what's going on. So the way that you might want to get Zig would be going to the download page here. And we already have improvements beyond the release that came out yesterday, so that's why we have master branch tarballs here. But here's the release. Fun thing is that we have this bootstrap tarball here, and this lets you build Zig with Zig using only a system C compiler, and then build it for any target. And that's in fact how we produced all of these tarballs with the bootstrap repository. One thing to note is that I did a little bit of an experiment on the x86 64 tarball. It's V2. So if you look at the Wikipedia page here, they have this microarchitecture levels section. And this baseline thing is what we used to do for all the x86 64 tarballs, because it's just guaranteed to work on everyone's old ass hardware. So I changed it to this one, thinking you would, that it's still pretty old, right? Like the newest one is 4. And I figured everyone would have these by now. But you know what? I'm seeing some reports in the wild that that's not the case. So I think for 0.8.1 and beyond, we'll go back to baseline. So we'll sacrifice a little bit of performance in the binary distribution in order to make it just work. And I think that'll be the way to go. But if you see illegal instruction in this one, that's probably the thing to look out for, or in this one. But for most people, if you have a modern CPU, it's gonna just work and it'll be a little faster. So I don't know, just look out for that. And then in the future ones, we'll go back to baseline, because I think I've seen enough people say, hey, I had old hardware and I wanted it to work for my old hardware. Anyway, I have a couple demos to share with you today. So I just wanted to go over some of the fun stuff here. And I pointed out this section just a minute ago, reworked memory layout. this section talks about data-oriented design. And one of the things that I pointed out that we were able to do is take advantage of structive arrays data structure in order to improve memory layout. So if I follow this link here, this is actually a new standard library improvement that is available. And some programming languages have experimented with trying to actually add support for this directly to the language, for better or worse. But I found out that you could just implement this in Zig, and it works great. I wanted to show you the implementation, actually. So if I pull up my good old editor here, and I pull up multi-array list, I want to show you the implementation. So it's not even that long. A lot of these are tests. So if I actually go cut off the tests, we're looking at a 400-line file. So 400 lines of Zig. And I don't want to bore you with the super low-level details. I just want to give you kind of an overview of how this structure works. So it has only 3 fields, and they're all pointer-sized. So that's the overhead of this structure. And then there's this part here is really interesting. So this is code that runs at compile time. And what happens is that the way that you use multi-array list is you pass it a struct, and that struct tells the multi-array list how to it tells it about the fields. It turns that struct from an array of struct into a struct of arrays. So this code here iterates with reflection over the fields of the struct, sorts them at compile time, and then produces the data that we need in order to do the computations at runtime in order to make this data structure work. And that's it. I just wanted to show you, like, it's not like template magic or macros or anything weird. Like, all we had to do is just like a little bit of what is it called when you a little bit of loop unrolling at compile time, and again a little bit of loop unrolling here, and that's all you got to do to implement this data structure. It actually came out to be like a pretty clean API. So I want to show you using it, and I'm just going to copy paste this one here because I think it's a good example. I mean, I took the time to make it, might as well use it, right? So I'm going to paste this right here. I guess we'll go into build release. So this is the example I came up with. We have this struct here. This is just whatever, it's a struct. And I have this code here and this code here. And these blocks are identical, except one of them uses array list. And one of them uses multi-array list, the one I was just showing you. And then we call the same function, and then we use the general purpose allocator to measure how much memory it took in order to store the data. And then that function here, the reason it accepts either type is because we use any type here, so you can pass both. And they both have the same API. They both just let you call append like this. So here we're just adding 10,000 items to the list. And we do it for array list, and we do it for multi-array list. So if I run this, actually, yeah, I'll just do it here. If I run this, actually, you know what? I don't want to make this look like I'm using a development environment. Let me just copy paste this to just a whatever folder in my temporary directory here. There we go. Okay. Yeah, and I'll just use the Zig that's in my path. All right. So if I just run this, it's going to run this print, and it's just going to tell me how much memory got allocated for each one. And so you can see here that the appending of 10,000 items to the array list took 160 kilobytes, but appending the same data to a multi-array list only took 91 kilobytes. This is probably something that should be addressed too. Don't worry about that. Not the point. So That's a lot smaller, right? I mean, if we want to find out how much smaller this is, I got to pull out my calculator because I can't do math in my head anymore. What is that? 1.8 times smaller? Is that the right way to put that? Anyway, it's much smaller. And on modern CPUs, LS CPU, grep for L1. So this computer has 256 kilobytes of L1 cache. So, so what's the difference here? 160 minus 91. That's 69. Nice. So wait, no, that's not what I wanted. Wrong move. So my point is that the difference between this amount is 25% of the L1 cache. So the amount of data that this saves is actually like pretty significant. But why? Why is it magic? Like, what's going on? Answer is really simple. This struct has a tag which is 1 byte, right? This is essentially a Boolean. You know, an enum with 2 values only takes up. I mean, really, it's 1 bit, but let's say it's a byte. And then we have a pointer. And now the thing is that a pointer is 8 bytes aligned to 8 bytes. And that property has to stay. So if we want to put 2 of these things in a row, and we want this pointer to have the right alignment, we actually have to insert 7 padding bytes in order to make this field get properly aligned. So actually, this field ends up being 8-byte aligned because of the field after it. So if you think about it, we're wasting 7 bytes for every single one of these. And that's where the difference between these 2 values comes in. When you do a struct of arrays, which is what this does, we're having an array with only bytes in it and then an array with only pointers in it. And so we don't have to waste those 7 bytes for each element. And in fact, let's check if I'm right. Let's do my math here. So it's 10,000 items from this number right here. And it's 7 bytes wasted per item. So then we divide that by kilobytes, and there it is. I mean, we're off by probably like the overhead of the allocator or something, but that number matches this one. So that's multi-array list. And that's one of the things that was added to the standard library in this release. So you can go get that API right now, and you can use it. And as you can see, it's very clean. It's very easy to use. Just pass it a struct, just like you would pass to an array list, and then you can just use it like an array list. The API is slightly different if you want to access stuff, but that's intentional. That's the way that you want it to be different. So anyway, just wanted to show off that data structure. I'm very pleased with the implementation, and I'm pleased with the way that the language lets you do this abstraction in a clean way, and also a way that does not compromise in performance without having to change the language. Like I think it's an example of the comp time features of Zig holding up. All right, so that's that demo. I think I probably spent like 5 minutes on that or 10 minutes on that. So let's just get through a couple more demos, and then I'll stop yapping my mouth, and we'll play some Secret Hitler. Okay, Jakub definitely wanted me to demo something. So here's the demo he sent me. Go to here. Hello, wasm.c. All right, next demo. This is the hello world file that WebAssembly or WebAssembly system interface gives you verbatim. And Jakub wanted me to show this. So the demo is we compile. Yeah, that's it. So we compile the C code with ZigCC for WASM32 WASI, output to here, and then we run it with WASM time. So this example reads from an input file and outputs to an output file. Okay, and then we got to verify that the output worked. Oh yeah, it worked. I know the macho man.
Nice.
Thank you. I wrote this poem myself.
Oh,
All
he's
right,
in
so that's
chat.
that one.
He's in chat and appreciating.
All right, so that's that demo. And then I have one left, and then I'm gonna turn it over back to Loris. So I want to show off some of the incremental compilation of the self-hosted compiler. Let's go over to, not that one. Not that one. Where am I trying to go here? This is fine. Okay, so I have a build of Zig here. Wait, why do I keep going to my dev environment? I should just keep showing it off with my temp directory. Okay. Let's see what we got here. So I'm going to need 2 terminals for this because I'm going to show you incremental compilation. And I do need to reference some of these passing test cases. Okay, I typed vi instead of vim on accident, and now nothing works. There he is. Okay, let me just grab some of these test cases. Okay, so Zig, we have Zig. Great. We now have this watch flag. So if I do build exe test.zig, okay, what is test.zig anyway? Let's make it an empty file. Start with empty. Yep, that does make sense. Oh, I'm trying to use the self-hosted compiler. That's why I keep trying to use my dev environment. That's the stage 1 compiler. Okay, right. So let's go use self-hosted. So we're here. Build least test. I'll start with an empty file like promised. Now I need to, if I use Zig, we're still not shipping self-hosted, but I can build self-hosted. And I'm gonna build it without LLVM installed. And I'll show you that without LLVM installed, we're missing some features. So for example, the Zig CC feature depends on Clang and LLVM and LLD. And so that feature won't be available in this build that I'm making. But that's the point. I want to show you what we do have working that does not depend on LLVM. And so I do, also I apologize, I didn't prepare enough for this demo because I was so exhausted, but it's fine, I can do it. We can do it live. Okay, so I have this build now. This build does not have LLVM extensions. So if I do, for example, Zig CC, hello, okay, and I got undefined behavior, that's bad. All right, I don't know why that happened. Anyway, not the point. Oh, I made a debug build. That's not undefined behavior. Okay, so anyway, point is, there's this new flag. It's called watch.
Andrew, can you put a couple of new lines on the terminal to the right? A bit more? One line more? Okay, thank you. That's where your webcam is.
Got it. Thank you. There we go. Okay, so this watch flag is activating a REPL, kind of, but it's not. It doesn't support any comp time expressions yet. I think we could probably add that, but it's actually a driver to the compiler. And so these are the only commands available so far, but let's play with them. So if I do update and run, I can't do that because I have an empty file, and there's my error. And so I will go ahead and make the simplest possible thing here. And now if I hit enter, it will do the same thing. So that actually did run the empty program. And I can prove it to you because if I go into the standard library, just deep inside code that's not even excuse me, not even used by this empty file. So if I go to, for example, I don't know, net, and I introduce a ASTgen error somewhere, like for example, let's say I just like redundantly let's do this, but that's a conflict with the previous one. I save that. Oh no, my demo failed. I should be getting an error here. Did we just not detect that? Let's try this one. Yeah, I don't know. Well, this is what I get for not testing my my demos. Oh, never mind. I know what the problem is.
Is that the right standard library?
It's the wrong one. It's the wrong standard library. Yeah. In fact, it should be this one, because this is picking up the Zig installation inside the release folder, not inside the standard library folder. That's exactly right. So let's try this again. That's the other reason you got to practice your demos, because even if there's no bug, you might be doing it wrong. There it is. So my point is, this file doesn't do any networking, but the point is that the self-hosted compiler does a lot more checking than it used to. So you can see that we found this error immediately, despite this being our test example. So the compiler is actually generating, it's actually tokenizing, parsing, and generating CIR code for the entire standard library every single time. Of course, it does caching, so it noticed that this was the only file changed. It didn't have to repeat any work. So, all right, I haven't tested this. Let's see if it recovers from this error going away. Nope. So this is obviously a bug in incremental compilation. And the good news is, though, our test suite is set up so that when you create a test and then you add changes to files, so we can actually just simulate this this test case perfectly inside the test suite and add coverage for it. But anyway, I'll put that back on so that we can see we got this back to going update and run. So let's go on to the next one. Let's see if we can recover from this. So I can't just import the standard library and call print. So I can import the standard library, but we're going to run into language features very quickly that aren't implemented yet. So for example, if I do IO get standard out dot write all hello. Let's see how we do here. Yeah, so we ran into, I don't know, some kind of bug in the compiler because it's activating stuff that we don't have support for yet. So in other words, in order to do a demo here, I need to actually just kind of call into some inline assembly and exercise the compiler a little bit less. But this will, in fact, do a print. And if I go mess with the message, oh, wait, there's a length here. Does this work? Nice. Oh, I didn't put the new line in there. There we go. So you can see this kind of thing works. Could do this kind of thing. So, there's obviously some bugs that we just observed, and I'll get those worked out. But here's the thing to think about. This is incremental compilation. It is integrated with the standard library. In fact, it's even having to deal with all this start code, this comp time block. Like the code that actually calls main is here. So it's doing a lot. A lot is working, despite the simplicity of this test case. And what I want you to think about is, imagine an IDE that is using this in the background. So obviously it doesn't have to use the command line, but you press the big green button on the IDE and it does this. Or actually, just as you type, it would be doing this one, and the green button would do this one. And when the errors, when the compile errors happen, they can show up inline in the text editor, and we can start to add more tools here. Rename, refactor tools, like searching documentation, finding call sites, finding declarations, all that stuff. So, obviously, there's some work to do because this feature is hard. It's hard to implement. But I made a lot of progress on the stability of this in this release. And imagine that we get this working smoothly with an editor, and it's fast, and it's the actual compiler running in the background, compiling your actual binaries and giving you actual error messages. And so you'd have an IDE that just completely integrates with the compiler and lets you have that that experience. Like, I don't want to be using Vim for the rest of my life. Come on, give me I want the eclipse of Zig. So yeah, a little rough here. My bad for not practicing the demo more, but I think you can kind of see where this is going, and the infrastructure is in place and it's going to work. Like, it's the concept is proven. So that's it. I think that's going to be it for my demos of the compiler here. And I don't want to hog all the time here. So I think we're going to do some more stuff, like take questions from the audience. Is that right, Loris?
Yes. So, by the way, Andrew, you just said that you don't want to use Vim for the rest of your life. I think you cause Hayes to have an aneurysm or something, but.
The nice thing about Vim is that it works even if your programming language doesn't exist yet, and you know what I mean? Like, you can just type in imaginary code and it actually works pretty good for that. But once your programming language exists, gotta get better tools.
Well, some people in chat are saying, well, you could. Oh, I don't know if they're saying this, but it makes me think like maybe you can upgrade to NeoVim. Or is that not enough?
What's the difference?
I don't know. Just joking. Okay, so well, thank you for the demos. 7 months for the self-hosted compiler. Then you just made a public promise.
Yeah, I did. Yeah.
That's a terrible mistake when it comes to software,
Bring it on, motherfuckers. That's what I say.
Okay. So, well, everybody, you heard him. I've seen, so we made the release announcement on, by the way, sorry, before I continue running my mouth. So Q&A, if you have questions for Andrew about the release and roadmap, that's the time. We are not going to do a ton of questions because we want to kind of move on to the second half of the show and not have showtime last too long. But so this is the time. In the meantime, while people start thinking of questions, I just wanted to point out that there are we made announcements for the new release on like Hacker News and other places, and it was nice to see that everybody is pointing out how there's a lot of nice energy around Zig. Little do they know that we are not yet there. We are not yet at the we are still going up the roller coaster, I would say. I think we're about to reach the part where you start accelerating a lot, but we're not even there yet. So
I completely agree. I think that we are going up the roller coaster until self-hosted's done and the package manager are available. And I think once the package manager is generally useful, that's when the roller coaster starts going down.
Yeah.
And we all put our hands in the air and scream.
Yeah. Holy shit. Yeah, that's going to be awesome. Also, from my perspective, also the fact that we are getting out of the pandemic, social events are starting to happen. Mm-hmm. We're going to have Zig meetups. Right? People watching, it's going to be your job to bring Zig to your community and have local meetups. and that's hopefully is gonna all come together up to one day having a Zig conference. So
That would be great.
Yeah, actual physical meetings, yes. I mean,
Yes.
it's about time.
I am fully vaccinated and I'm ready to make out with everybody and lick doorknobs and shake hands and then all that good stuff.
Nice. Okay, so let's see. Questions. I think I saw one or two. Let me see. What are the scenarios where you would prefer an array list over a multi-array list?
A array list is fundamentally simpler. It's just a bunch of stuff in memory in order. So if you don't need so it's the null hypothesis is the array list. And so the question is, well, when do you reject the null hypothesis? And I think that if you don't have a problem with your code, you don't need to introduce destructive arrays. The time when you want to do it is when you are examining the memory layout of your program and you're thinking, okay, I do want to make the memory layout in this area here. I care about it. I need to make it as small as possible. Maybe you can identify in your program, this is the object that I'm heap allocating all the time. It's the one that I'm, that I have so many objects of in memory. That's the one I need to memory optimize. So now you're looking at it and you're thinking, okay, how can I make this memory smaller? How can I make this state be represented in a way that requires fewer bits? And then at that point, a multi-array list becomes a tool that can help you accomplish that goal. So the way to think about it is less of like, oh, when is this data structure the right tool for the job, and more of this is in my toolbox that I might bust out with it when I'm trying to organize memory in a certain way. Does that make sense?
I think it does. So there's a profane perspective that came to my mind while you were demoing it. So maybe that also can help some people. And you can tell me if you think the parallel holds and to what degree. It reminds me also what people do. So I was in the database world for a while, and in the database world, there's this distinction between row databases and column databases. So multi-array list is basically a column representation of your data structures. And generally speaking, column databases tend to be good for analytics. Like you want to get the average of a column, which corresponds to a field in a struct, and that's much more efficient because you don't have to skip.
Yeah, that's a good point. Can the people still see my screen?
I can bring it up, sure.
Yeah, also, so I just wanted to, thank you. So again, showing off that on this computer, the L1 cache is this amount of data. The other thing to note is that there's a granularity to this, and it's a cache line, and it's 64 bytes. So you can't just load 1 byte of cache. You're always loading a 64 byte aligned chunk of memory into the cache at a time. So yeah, so if you had, ABC, or if you had, 3, 4, B, C, imagine this was like times 64. And if you're, it's the column database thing, right? So if you have to, if you're trying to do average of the A column, you load this one, you skip these ones, you load this one, you skip these ones, you load this one, you skip these ones. So if you think about it, every time these are taking up space in the cache line, but you're not looking at the data. Versus if you just had 64 of these and you're averaging them, all of the data that you're loading into cache is relevant to your computation. You're not wasting the time looking at these because they're elsewhere. So yeah, that would be another time to think about it. Oh yeah, and I wanted to point out that book that I was mentioning, worked memory structure, right here, data-oriented design. This was the book that kind of helped me figure it out. If you look at it, I recommend skipping this chapter completely. Just skip straight to here. This is the good stuff. And the whole point of this chapter is that actually relational databases just kind of like contains the answer to data-oriented design, and you should just think about databases, and that's where all this comes in. This to me is the book. I'm not even sure I recommend any of the rest of it.
Cool. Okay, let's see. More questions. Do you think CompTime will eventually be just as powerful as runtime, like CompTime heap allocations seamlessly transitioning to runtime, etc.?
There's always going to be a limitation of comp time because, we have to simulate that the comp time code is running on the target, not on the host. So, for example, if you're cross-compiling and you're cross-compiling for, I don't know, ARM 32-bit, but you're running it on x86 64-bit, we need to actually execute those instructions at comp time as if you were running them on the ARM computer. So there's certain things that comp time code will never be able to do. So you can't load dynamic libraries from the host system. You can't do like network access, inline assembly. You can't crash the compiler in theory. But specifically for allocations, that should work because allocating memory is something you can do anywhere, pretty much. So, but I think there's some hiccups with that. So there's an issue you can track. So go to comp time allocator. There it is, 1291. So if you go to this issue 1291, I don't know why it's not loading for me. There it is. And just click subscribe over here. Then you can find out when it starts working.
Nice. Okay, I think we can stop here with the questions. I don't see any other question in chat, and I think I want to say, so we are going to play now, after the break, a nice tabletop game. Andrew already spoiled it, Secret Hitler.
Oh,
but
I'm sorry.
It's fine, it's fine. I also said it in the newsletter, but I have a nice intro for it, which I think I'm gonna do afterwards. I think it's a nice starting point because, I mean, hopefully people that are here watching the release us demo stuff and talk about release notes and everything else might be wondering why are these people playing a tabletop game on stream for the release notes? Like, can they have fun in private? Yes, but no. Yes, but actually no. So I'm gonna try to also give some perspective there. But before that, I would like to say, well, Andrew already thanked everybody, contributors, a lot of contributors. Thank you very much. Sponsors also that have been supporting us financially. Thank you very much. Just so you know, we have had for a while now a new goal on GitHub sponsors. We are close to halfway through, almost there, 40% more or less. Which is a goal that would allow us to have more people join the Zig Software Foundation full time. You've seen that your money is being well spent. There's a lot of work that has been done from one release to the next. So if you're enjoying Zig, please consider supporting us. I think I wanted to say something else. Oh yeah, and also thank you to all the people that haven't necessarily been contributing code to Zig, but that have been helping making the community a better place. So thank you, Sob, for Ziglearn. Thank you also for Ziglings by Radfactor. Thank you to everybody who wrote blog posts and also, even just answering questions in Discord or in other places. Thank you very much for your support. It's a lot of work, not just doing the things, but also explaining them to other people. So every little bit helps. And just so you know, your contribution is really appreciated. At least I am monitoring everything, and I reply to a lot of things, but not to everything, because sometimes somebody is giving a better reply than I would be able to. So that's awesome.
And you know why we do it, right, Loris? Why we do everything?
Why?
For the end users of the software.
Right.
That's right.
Right. And I love being the end user. fuck it. I would be happy to give up programming if I could have everything that I want already programmed by somebody else.
Yep.
Okay, so with this, I think we should go on a break, and then it's gonna be Secret Hitler. So thank you very much, Andrew. Is there anything else you want to say before we go to the break?
Yeah, I heard that there might be fascists among us.
There might be. Okay, let's go. Where's the scene with the break? There we go.
Right there.